Great. So hi everyone, I'm Itay, and today I'm going to talk about actionable insights from the content of websites, which is about an applicable system that we've created here at Intel. It was a collaboration of the sales and marketing analytics team and the R&D team. So first, a bit about our group. We are Intel's IT AI group, and our goal is to integrate AI into Intel's critical work. We exist 11 years. We have more than 200 AI professionals that include data scientists, developers, analysts, and more. And we've already produced more than 500 solutions in the fields of sales, design, manufacturing, and more. I'm first going to talk about what motivated the system, then I'll describe it, then one quick modeling slide, and then my main focus, which are 3 key challenges and how we solved them. So we want to understand what a company does, or to profile a company. There are many reasons why we would like to do that. I'm going to name 3 of them. First one is we have what we refer to as hunters. These are sales development representatives that try to identify potential customers for Intel. And once they do, they will actively engage them. Now, the problem is that before our system, they had to manually try to understand what a company does. And there's a huge pool of companies. So this process, and only a small portion of them were relevant. So this process was very time consuming. Second is an internal initiative called Marketplace. And this is a matchmaking platform that helps our partners to find customers. The idea is simple. What's good to our partners is also good to us. And thirdly is we have an internal knowledge graph, which is a database with informative entities that we can use to solve many different problems in the present and in the future. And we want to enrich it with quality data. And once we
Itay, do you hear us? We lost you. We lost the communication.
Sorry, I got disconnected. Can you hear me now?
Yes.
Great. I'm going to describe the system now. We have a list of target companies. This is a very large list, 100,000 of companies. And we automatically extract data for these companies that we can use to profile them. This data, the main data that we use is everything that is available from their websites. This includes HTML, images, metadata, and others. And we also use external data, for example, Wikipedia. However, only small portions of companies appear there. So the main data that we use is the website. Then we perform extensive NLP processing, modeling, and then the system yields predictions. What is the profile of each company? And this system can label more than 10,000 domain or companies daily. The labels that we use are divided to 3 categories. We have the functional role of the company. Is it a manufacturer, a seller, a distributor? The type of products it produces. Does it produce software or smart devices? And the segment that it operates in. Is it healthcare, automotive, education, or others? And this is inherently a multi-label problem. Not only that each company can have labels in all 3 categories, also within a category, it can belong to different labels. For example, a company can be both in communications and cloud computing. The main data, the HTML, is processed as following. We first use clever heuristic to segment it, and then divide it into a bag of words. These would be words that have no temporal dependency between them, and sentences, and each of them will go into a different modeling route. First, we wanted to understand if the HTML data is indeed informative about what we want to achieve. So a simple exercise we did was, for each category, we calculated the TF-IDF scores and ranked the words accordingly. And you can easily see the difference. For example, in education, you get students, then alumni, then campus, faculty, and so forth. In digital security surveillance, you get surveillance, camera, alarm, IP. So it makes sense, and this implies that we can indeed do something with this data. It shows a signal. In terms of modeling, we performed a comprehensive model selection. We tried out different feature extraction methods, TF-IDF and PCA, word embeddings like GLOV and BERT, LDA, a combination of all of these. We tried out classic baseline model for multi-label problems, methods of problem transformation, algorithm adaptation, ensemble methods, deep learning baseline models like a one-dimensional CNN, a fine-tuned BERT, and also more advanced modeling methods. These are networks that we created ourselves, customized to the problem. For example, a multi-channel network where we input different types of data and then combine them. And this was actually the outperforming model. This was the best model. Now, I'm not going to focus anymore about the modeling part. Optimizing the model is important. However, we realized that optimizing the data is even more important in terms of performance. And most of our time and effort went into this. So our three data optimization challenges were a meaningful web page extraction, obtaining more labels, and the problem of auto-distribution. So I'm going to shortly describe each of them and how we solved them. Starting with web page information. So web pages are made for humans, not for machines. HTML, CSS, and JavaScript are messy. And as humans, it's enough for us to get a quick glimpse at a web page, to segment it, and even in some cases, we can quickly understand which segments of the page are more informative for us. So we wanted to do something similar. So we first want to somehow segment pages. We can do it in several ways. For example, we can use the DOM tree information, but we can also use more sophisticated methods like Microsoft VIPs, which exploits visual cues like fonts and font size and colors in order to segment a page. And once the page is segmented, then we can pass these segments into Amazon Mechanical Turk, crowdsourcing, in order to, and ask them to say which of them is more informative to what we want to achieve, to what the company does. And once we have labels, we can use a classifier and supervised learning in order to classify the rest of the segments and future segments. We do that by using meta features. For example, the position of the web page, of the segment in the web page, aggregated statistics like the number of stop words, total word counts, HTML tags, which are very informative, and others. It's not only that we're not only interested in the information conveyed by segments in a page, but also which pages are informative. So what we can do is easily extract the URL of a page and parse it, and then the parsed words can be used to assign it to one of predefined categories. And then we can use these categories either to learn weights in the model, or we can also apply the pages in separate channels in a multi-channel model. Labels in this case are expensive. We can't just use crowdsourcing to get labels. When I mean labels now, I mean the profile of the companies. The reason is that If you ask a company what it does, it sometimes tell you, oh, we do everything. But in reality, they specialized in only several things. And also the taxonomy is different. We have specific labels that are relevant to us. And therefore, we want the companies to be labeled by our internal experts. And this is a bottleneck in that sense. And we also show that performance is tightly related to the number of labels that we have. Here we see the F1 performance for each category. So there's a strong dependence. And in order to gain more labels, we have two solutions. The first one is to use Wikipedia. In NLP, we call this process wikification. So what we do is we extract, so we get a list of companies, organizations, relevant institutions, and corporates from Wikipedia. And then we can easily extract industries and products from these pages. Now, this poses two problems. The first one is the problem of standardization, because Wikipedia is written by people. And therefore, a lot of products and industries will be duplicates, or they will be very, very similar. And we somehow want to standardize them. So the way we solve this is by computing the relatedness between pages. And the products and industries are also pages. The relatedness would be done using information of ingoing and outgoing links, and also the content. And once we have this related measure, we can compute a graph, we can form a graph, and then cluster these or standardize these labels according to graph distances. The second problem is that the labels are different. It's not the same taxonomy. So we somehow want to transfer the labels to our own taxonomy. So one way to do it is using transfer learning. So we train a model with the Wikipedia companies and their labels. And then for the rest of the data, we extract representations from this model and transfer it to our taxonomy, to our labels. And the Wikipedia labels are very high resolution, so this makes this representation richer. Second solution is to use weak supervision. So for that, we utilize a useful tool called Snorkel, which allows us to define weak labeling functions. These are, you can think of it as a set of rules that automatically can label each company with noisy labels or fuzzy labels, and then these labels are used for the main supervised model. The last problem is the challenge of out of distribution. So we have our relevant labels that we want to assign, but in the population or inference data, we also have a lot of irrelevant labels like cosmetics, food, clothing, and if we don't somehow account for these, then the model can mistakenly assign the wrong label, and sometimes also with high confidence. So to account for them, we again use Wikipedia, and we look for companies with these labels, and then we add them to our training set. And we also use one general label that that attracts all the rest of the labels that we don't have, and this significantly improves results. Our F1 scores are satisfactory and they improve by the day. But more importantly, 50 to 70% of the companies that we deliver to our hunters are accepted as relevant. If you want to learn more about or to read more about the system, that we published a paper called Learning a Faceted Customer Segmentation for Discovering New Business Opportunities. It was published in IEEE Big Data. So to summarize, we wanted to learn a company profile. This serves a lot of purposes. The profile is consisted of roles, industries, and product type. For lead generation, this causes a large speed up and saves a lot of time and effort. And I talked about 3 data optimization challenges and how we solve them, which is efficient context extraction, increasing the number of labels using wikification and wiki supervision, and finally adapting to irrelevant labels for the population data. Thank you for listening.
Thank you, Itay, very much. Very interesting presentation.